dawn has not yet broken, and already a star is blazing on the horizon. It shines so intensely that it cuts through the morning haze. Once convincing ancient civilizations it was a divine omen. But if you could move closer, you would not find the glow of love. You would see a yellow, suffocating sky, a reddish surface scorched to 465 degrees Celsius, and pressure strong enough to crush a human body within seconds. That is Venus. The second planet from the Sun, orbiting at an average distance of about 108 million kilometers. Its diameter is 12,104 kilometers, nearly the same as Earth. Its mass is 81% of Earth's. Its density is strikingly similar. An iron core, rocky mantle, solid crust. Its internal structure is almost a twin of our world. For decades, astronomers called it Earth's sister planet. But this twin chose a radically different path. Venus is the brightest object in the night sky after the moon. It does not generate its own light. Its thick cloud cover reflects more than 70% of the sunlight that strikes it, making it shine like a diamond. The Romans named it after Venus, the goddess of beauty and desire. Long before them, Babylonian, Greek, and Mayan astronomers carefully tracked its cycles. At one point in history, humanity believed the morning star and the evening star were two separate celestial bodies. The truth is stranger than myth. Venus rotates in the opposite direction of most planets in the solar system. If you could stand on its surface, assuming survival were possible, you would see the sun rise in the west and set in the east. But one full rotation takes about 243 Earth days. Meanwhile, a year, its orbit around the sun, lasts only about 225 Earth days. A single day is longer than an entire year. Nowhere else in the solar system presents such a paradox. Yet what truly stunned scientists was not its motion, but its atmosphere. Venus's atmosphere is composed of roughly 96.5% carbon dioxide, with most of the remainder being nitrogen. A global cloud layer stretches from about 45 to 70 kilometers above the surface, filled with concentrated droplets of sulfuric acid. Winds in the upper atmosphere reach speeds of 300 to 360 kilometers per hour, creating a phenomenon known as superrotation, where the atmosphere circles the planet in just about 4 Earth days, far faster than the solid surface beneath it. Beneath those clouds lies a planetary greenhouse. The greenhouse effect here is not merely strong, it is extreme beyond stability. Surface temperatures average around 465 degrees Celsius, hotter than Mercury, even though Mercury is much closer to the Sun. The reason is simple. Mercury has almost no atmosphere to trap heat, while Venus is wrapped in a carbon dioxide blanket about 90 times denser than Earth's atmosphere. Surface pressure reaches roughly 92 bars, equivalent to diving nearly 1 kilometer beneath Earth's oceans. Lead would melt. Tin would liquefy. Zinc would vaporize. There are no oceans, no rain of water, no weather cycle as we know it. In the upper clouds, sulfuric acid rain may form, but it evaporates before ever reaching the ground. The surface is a vast expanse of lava plains stretching thousands of kilometers, dotted with thousands of volcanoes. Radar observations have identified more than 1,600 major volcanoes, with potentially hundreds of thousands of smaller volcanic structures. Maxwell Montes, the tallest mountain range, rises about 11 kilometers high. And perhaps most unsettling of all, Venus's surface is geologically young, estimated to be only 300 to 700 million years old. This suggests the entire planet may have been resurfaced by massive global-scale volcanic eruptions, a world once remade in fire. From a distance, it appears brilliant and beautiful. But beneath those shimmering clouds lies a climate system pushed beyond control, a state that, once entered, offers no return. And this is only the beginning of the story, because there is mounting evidence that Venus was not always like this, that it may once have been cooler, that it may once have held water, that it may once have had a chance to resemble Earth, a near twin planet, transformed into a permanent inferno. What forced it across that irreversible threshold? Imagine a morning on Venus, more than 4 billion years ago. The sun was fainter then, its light weaker, softer. Modern climate models suggest that under those conditions, Venus may once have possessed shallow oceans, stable temperatures, and a sky not yet stained the suffocating yellow we see today. No one was there to witness it, but the chemical traces left behind in its atmosphere tell a story that cannot be ignored. The ratio of deuterium to hydrogen in Venus's atmosphere is more than 100 times higher than on Earth. Deuterium is the heavy form of hydrogen. When water molecules are broken apart and lighter hydrogen escapes into space, deuterium tends to remain behind longer. That abnormal ratio is a silent confession. Venus once held vast quantities of water and has lost almost all of it. The collapse did not happen overnight. It was a chain reaction. Venus orbits about 30% closer to the Sun than Earth does. In climate systems, 30% is the difference between stability and catastrophe. As temperatures rose, water began to evaporate. Water vapor is a powerful greenhouse gas. The hotter it became, the more water evaporated. The more water vapor accumulated, the more heat was trapped. A feedback loop accelerating beyond control. At a certain threshold, the oceans were no longer regulators of temperature. They became fuel for disaster. As water flooded the upper atmosphere, ultraviolet radiation from the sun tore H2O molecules apart. Hydrogen escaped into space. Without a strong magnetic field like Earth's to shield it, Venus lay exposed to the solar wind. The remaining oxygen reacted with surface rocks, or was stripped away. The oceans vanished without leaving a trace of waves. Once the water was gone, the carbon regulation system collapsed with it. On Earth, carbon dioxide dissolves in oceans, becomes locked in limestone, and is recycled through plate tectonics. Venus had no oceans left to absorb CO2. Nor did it possess an active plate tectonic system like Earth's to draw excess carbon back into the interior. Carbon dioxide accumulated over hundreds of millions of years, transforming the sky into a thermal blanket tens of kilometers thick. It was not merely hot. It stabilized at a lethally hot state. Then came humanity's reckless missions. From the 1960s to the 1980s, the Soviet Union launched a series of Venera probes. Many were crushed before reaching the surface. Others melted within minutes. Venera 7, in 1970, she became the first spacecraft to transmit data from the surface of another planet. The faint stream of signals lasted less than half an hour. Venera 13 and 14 in 1982 sent back the first color images: shattered rocks, dim orange light, a horizon blurred as if inside a metal furnace. Instruments recorded temperatures around 457 degrees Celsius and pressures about 90 times that of Earth. Not a single probe survived longer than 2 hours. In the 1990s, NASA's Magellan spacecraft used radar to pierce the dense cloud cover. The images revealed not a silent world, but one marked by hundreds of dome-like structures, massive lava flows, collapsed craters, and plains stretching for thousands of kilometers. Venus's surface is relatively young, evidence that it may have undergone widespread volcanic resurfacing events, capable of remaking nearly the entire crust in a geologically brief period. A planet burned from within. But the story does not end in the past. In 2023, scientists reanalyzing old Magellan data detected changes in the shape of a volcanic vent between imaging passes. The findings suggested that volcanoes on Venus may still be active today. Not a fossil, not a dead world. It is alive and still erupting. Then, in 2020, came a shocking announcement: the detection of traces of phosphine in Venus's upper clouds. On Earth, phosphine is primarily associated with biological activity or industrial processes. At altitudes around 50 to 60 kilometers above Venus's surface, temperatures and pressures resemble conditions near Earth's surface. The idea of microbial life suspended in acidic clouds exploded across the scientific community. Then came controversy. Some research teams failed to confirm the signal. It may have been sulfur dioxide misidentified. It may have been instrumental noise. The debate remains unresolved. Yet the mere possibility that microscopic life could exist in that toxic sky has propelled Venus back to the center of planetary science. A world that once had water, once had a chance, crossed a climatic threshold it could not reverse, and now, perhaps, still holds secrets suspended within its acid-laden clouds. Venus is not just the hottest planet. It is the largest climate experiment ever conducted in the solar system, an experiment that ran out of control. And we are only beginning to understand it. Far too late for Venus itself. No human has ever walked on Venus. No footprints. No flag planted in alien soil. Only steel machines plunging downward, falling silent in a sea of fire. Yet precisely because we cannot set foot there, Venus has become one of the most intense scientific battlegrounds of the 21st century. After decades of neglect, dismissed as too hostile, too unforgiving, this planet is returning to the center of attention. Not because it is easy to conquer, but because it may hold the key to some of the greatest questions about life in the universe. In the coming years, new missions will plunge directly into that suffocating atmosphere. NASA's DAVINCI mission will drop a probe through the thick cloud layers, measuring noble gases, isotopes, and temperature structure kilometer by kilometer. It will analyze argon, neon, xenon, the lingering fingerprints from the planet's earliest formation. Those numbers could reveal whether Venus formed like Earth or followed an entirely different path from the beginning. VERITAS will deploy next-generation radar to map the surface at unprecedented resolution. If tectonic movement is occurring, if fresh lava flows exist, if the crust is cracking apart, it will see it. No more blurred images from the 1990s. This will be a sharp, uncompromising look into the interior architecture of a planet that may still be simmering. Europe is not standing aside. The EnVision mission will investigate the connection between core, mantle, and atmosphere. If Venus's core cooled and stopped generating motion, that could explain why it lacks a global magnetic field like Earth's. Without a magnetic shield, the solar wind has been free for billions of years to strip lighter gases and batter the upper atmosphere. At the same time, space telescopes like James Webb have begun observing Venus in infrared detail beyond anything previously possible. They may detect subtle chemical fluctuations in the clouds, signals too faint for earlier orbiters to capture. This race is not only about understanding Venus, it is about understanding the thousands of exoplanets we are discovering around distant stars. Many of those worlds are Earth-sized, and orbit within the so-called habitable zone. But distance alone is not destiny. If runaway greenhouse effects are more common than we assume, then many of those potential Earths may in fact be Venuses in disguise. A planet can appear perfect from afar, yet conceal a furnace beneath a toxic sky. To understand Venus is to learn how to distinguish paradise from inferno across tens of light years. And then there is a daring idea. Instead of landing on Venus, humans might one day live above its hellish surface. At around 50 kilometers altitude, temperatures range between 20 and 30 degrees Celsius, and pressure is close to Earth's. Physically, a mixture of oxygen and nitrogen is lighter than carbon dioxide, meaning a structure filled with breathable air could float naturally in Venus's atmosphere, like a colossal balloon. Floating cities have been proposed in engineering studies. They would drift within seas of acidic clouds, far above the molten landscape below. Yet the challenges are immense. Sulfuric acid corrodes materials, solar radiation is intense, and the chemical environment is relentlessly hostile. This is not pure science fiction. It is an engineering problem still awaiting solutions. Venus forces us to confront a stark reality. Life is not the default outcome for a rocky planet orbiting a star. It is the result of a delicate balance among heat, chemistry, magnetic protection, and geological cycles. Shift a single variable over millions of years, and the entire system can slide into a new equilibrium, stable but lethal. When you see Venus blazing in the evening sky, remember that it is not merely a point of light. It is the record of a planetary catastrophe, a natural laboratory where climate physics has been pushed to its extreme, a mirror reflecting what happens when a world's energy balance crosses a critical threshold. And what makes it truly terrifying is not the temperature, not the pressure, not the acid. It is the fact that everything there follows familiar physical laws. No magic, no supernatural accident, only physics, chemistry, and time. Venus does not scream. It burns silently for billions of years, and we are watching to ensure that its story does not repeat itself on the only world we call home.